students, welcome to DC Economics. I'm going to take you on how we can solve different Doglus production function. For example, consider a firm Doglus production function of output function of capital and labor, which is equal to 9L raised power over half times K raised power over half. The firm is a price taker in the input markets. Labor is paid an hourly wage of 12 and the price of capital is R, which is equal to 6. The firm sells its output at a price of 4 per unit. Maximize the profit function, that is P bracket KL is equal to product of the function of capital and labor, open and closed bracket, minus WL minus RK to determine the optimal level of each input the firm should use. From this kind of equation, we consider a firm Doglus production function as we observe is equal to 9L a half plus K raised power of a half, and define the firm is a price taker in the input markets. So labor is paid an hour wage of 12 and the price of capital is 6. So the firm sells output at a price of 4 per unit. So maximize the profit function, as we require to maximize the profit function of PKL is equal to product of function of capital and labor minus WL, where W represent wage, R represent out the interest rate paid to capital. So we need to determine to the optimal level. Solution now. Since we have the output of the function of capital and labor, that is 9L a half times K raised power of a half, and the firm is a price taker, so this could be a perfect competitive market or monopolistic competition. So the cost of production of inputs, that was a capital that was used and paid, that is the interest rate, but also the wage payment to the laborers, that was 12, and the interest rate or the price of capital was 6. But also now you are required to calculate down the profit function. The profit function form that is given as PKL. So the production of capital and labor is equal to production of capital and labor minus WL minus RK. So you're required to calculate the profit function, that is total revenue minus total cost. So we take out profit, that is total revenue minus total cost. So total revenue is price times quantity minus the total cost. So what will be the price? The price we have is 4, as was provided to the question. So we take out 4 times the output level. The output level is 9L raised power of half times K raised power of half. Then we minus the total cost function we have, that is WR, that is 12. When we plug in wage rate, that is the payment to labor, that is 12. Then we minus the RK, and the RK represent out the cost from the capital, that was 6, so it will be minus 6K. So production function will be equals to the profit function. We take out 4 times 9L a half times K a half, that will be equals to 36L a half, then times 4, that will be 4K a half minus 12L minus 6K. So let's take the like terms. We minus all the like terms and unlike terms. So we take 36L a half, then we minus 12L. So this would give out 20L a half plus, we take out 4K a half, we minus 6K. So this would give out, it would be 24 raised power of a half minus 2K a half. So the production function equals 24L a half minus 2K a half, as you can observe. So after understanding that, let's go quickly and solve the optimal level. So actually the optimal level, this is a level of maximization, whereby these firms can maximize the profit. Under maximization law, we need to calculate the optimal level of input factor of production, that is capital and labor, that was applied to make out a total output level. For that case, we may apply the Doglus production function, that is, we may apply the formula, that is, since we have the output level and we have the budget, the budget constraint for production, that is WL minus RK, that is equal to output. And we don't know exactly how much of output was produced, but we need to assume that the output level is Q. So from that point, we apply the Doglus function to solve for the capital and labor. So under MPK, margin product of capital over PK is equal to margin product of labor over PL. So PK is price of capital and PL is the price of labor. So how do we find the MPK, that is margin product of capital? We differentiate. We apply the first order derivative of dQ over dk, dQ over dk. So this will give out a half L raised power 9 over 2 L raised power of a half K raised power of negative a half. The margin product of labor is derivative of dQ over dl. So this would give out 9 over 2 L raised power of negative a half times K raised power of a half. For that case, let you take the function. Let's take you the MPK. Now plug into our formula, to the Doglus production formula. So our price of capital is equal to the price of the price of labor. That was the payment to wage rate. The payment to wage rate was 12 and the price of capital was 6. So when you take out the price of, we need to take out the price of labor. Now we take also the next equation for margin product of labor, the margin product of capital. So we need to put it here exactly that we have decided to take first the first function of margin product of labor to be in front, and to the left hand side, and to the right to be the margin product of capital. So the margin product of labor divided by its price 12, we take out the function of margin product of capital divided by its price, that is 6. Now let's cross multiplication over there. You obtain 9 over 2 L raised power of a half, K raised power of a half, over, let you take the denominator and numerator upward. So when you divide out 12 by 6, you get 61 over 2. So it will be 1 times 9 over 2 L raised power of half times K raised power of negative half is equal to, we take out 2 times 9 over 2 L raised power of negative half K raised power of half. So it will be 9 over 2 L raised power of a half K raised power of negative half is equal to, take 2 times 9 over 2, that will be equals to 9. So it will be 9L raised power of negative half. 2 times K is 2K raised power of a half. So for that case, we may decide to make out L or K the subject. So if we make out L the subject, we divide by 9/2 both sides. So we'll give out L is equal to 4K. How have we obtained the L which is equal to 4K? When you take out 9/2, when you consider to let me rub over here, so as you can see exactly what is L over 4K. So this has been obtained by taking out we take out the two function, that is 9/2, then we divide by, let me lab over here, so as you can see. So this is like to say it will be, when we take out half L raised to power of negative half is equal to K. 9/2 divided by 9 is equal to half L raised to power of negative 1, and 2 divided by K raised to power of negative half is equal to 2 divided by half. So we times negative 1/1 both sides, so as we can bounce out the negative. So remain with L is equal to 4K. So from L, which is equal to 4K, let you plug in the values of L to the production function of WL minus RK, which is equal to Q. So from L, we plug in 4K, that will be equals to wage rate, that is minus 6K is equal to 2. So 12 times 4K, 12 times 4K. This will be equals to 48K minus 6K, which is equal to Q. So 48K minus 6K is equal to 42. So it will be Q is equal to 4K. Q is equal to 42K. So divide by 42 both sides. K is equal to Q over 42. So since it's the value of K, we need to find the value of L. So let you plug in the value of K to L. So from L, which is equal to 4K, so from L, which is equal to 4K, L will be equals to 4. Plug in the value of K, that is Q over 42. So L will be equals to, so for that case, our L would be equals to 2Q over 21. So that will be the value of L. So since we have now all the values that optimize, that link to optimal level, that is 2Q over 21 and Q over 42. So from this value, Q over 42 and 2Q over 21, this will be the input factor that we applied for the optimal level. And if you decide to prove them, you may plug into the budget production function, that is 12L minus 6K is equal to Q. You observe that they bring the same answer of Q. So when you press Q, it will be H7Q minus 3 over 21Q, that is equal to Q, as you can observe. So L is equal to 2Q over 21 and K is equal to Q over 42. That would be the answer. Now let's go to question number 2. For example, if the production function, consider Franco-Brogan's production function which is homogeneous of degree of 1, Q is equal to 50K raised to the power of 0.4 and L 0.6. The value of output include the payment made to the labor, the wage payment to the labor, WL is equal to DQL over DL in a competition labor market. Also, the value of the output include the payment made to the capital supplies, that is RK, which is equal to DQ over DKK. Show that the sum of the total factor payment, that is WL plus RK, is equal to the value of the output. And where the example you are given WL plus RK, such that WL plus RK is equal to AQ plus 1 minus AQ1, where A is equal to 0.6. So in a competitive labor market, also the value of output include the payment made to the capital supplies RK, which is equal to DQ over Q. So show that the sum of the total factor payments is equal to DQ over DK. So show that the sum of the total factor payment is equal to DQ over DK, and show that DK, that WL plus RK is equal to the value of the output, and whereby WL plus RK such that WR plus RK is equal to AQ 1 minus A times Q1, where A is equal to 0.6. Solution. So since we are required to show how the sum of the total factor payment WL plus RK is equal to the value of the output, solution would be that we need to understand what we are solving. So as I told you, we are required to show that the sum of the total factor payment WL plus RK is equal to the value of the output. Solution. So the sum of the total factor payment is given by DQL over DL. The total sum of the factor payment is given by DQL over DL plus DQ over DK times K, which is equal to the output level, that is 50K raised power of 0.4 and L raised power of 0.6. So derivative change of dq over dl is given by taking from the product output function, that is 50k raised power of 0.4, L raised power of 0.6. When you differentiate dq over dl, the answer will be equals to 30k raised power of 0.4, L negative 0.4 times L. So later we will come to times with L. Now let's find the dq or dq over dk times k. That is another output factor payment. That will be equals to 20k raised power of negative 0.6 and L raised power of 0.6. So when you take out this value, that will be equals to now. When you take 30k L times L raised power of 0.4, you need to times with L. So plus 20k raised power of 0.6 times 0.6 times k, that is equal to 50k raised power of 0.4 times L raised power of 0.6. So let's take the like terms, the values k to be plus or to be added with the k values and L to the L values. So when you take out k values, that will give you 30k raised to 0.4 times L raised power of 0.6 plus 20k raised power of 0.4 times L raised power of 0.6 is equal to 50k raised power of 0.4 and L raised power of 0.6. So after taking that, what you need to understand from those functions, let you take k values. So you take out 30k, this is 0.4, then when you plus with 20k raised power 0.4, you obtain 50k raised power 0.6, 0.16, then plus. When you take L is 0.6, then plus L, that is 0.6, you obtain 50k raised power of 0.4, L is raised power of 0.6. So when we collect the like terms from those values and add, it obtains something like this. So in order to obtain the actual value, we need to underscore, we need to put a radical on exponential factors of 0.16 and 0.36. So when you put in the radical, the answer will be equals to 50k raised power of 0.4 plus L raised power of 0.6 which is equal to 40k raised to the power of 0.4 times L raised to the power of 0.6. So that will be the answer to the question part B. So that is how we do for the issue of Doglus. So the answer would be equals 50k raised to the power of 0.4 L z 0.6 is equal to 50k raised to the power of 0.4 times L raised to the power of 0.6. So that's mark the end. So this is DC Economics. Don't forget to watch and subscribe on other videos. Bye bye.